Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox, where I teach you how to become a middle school math master. Today, our objective is to solve two-step equations. So that's going to be like solving equations that include two operations on the side with the decimals. So we're looking at equations like 2x plus 3 equals let's go with 11. How about that? Let's try 11. 2x plus 3 equals 11. The reason why we call this a two-step equation is when you look on the side of the variable, all right, there are two operations present. There's a multiplication operation and there's an addition operation, which means we're going to have to undo two steps in order to be able to get the variable by itself. And that's ultimately the objective, is to get the variable by itself. So the steps for doing that, for solving equations, like this is a pretty big equation up here, don't worry about that. But the steps to doing that is, first of all, you've got to simplify your expressions on both sides of the equation. Then you've got to get all the variables to the other side of the equation. And then third, you have to isolate the variable. That means to get the variable by itself. That is the objective when you're solving equations, is getting the variable by itself. And there's an order, all right? You have to follow the order. It's not an incredibly hard order to memorize, but first you're going to undo all the addition or subtraction. So any additive component, you want to undo that first. And then second, you're going to undo any multiplication or division or any multiplicative component, all right? So you've got to follow that order. If you forget that order, then you can always remember in PEMDAS. I'm just showing you this slide. This is going to be another equation we're going to do here in a second. But you can always look at PEMDAS. All right, for simplifying expressions, you go from the top to the bottom. But for solving equations, to undo the math, you go from the bottom to the top. So first, you're going to start with undoing any addition or subtraction, and then you're going to go about undoing any multiplication or division. But let's go back to this equation that we've got here as an example. All right, we had 2x plus 3, all right? Again, in order to be able to solve this, we've got to work in a particular order. So we're looking on the side with the variable, all right, which is this side. It's got the x, okay? And we're going to undo all that math because ultimately we want to know what x equals, all right? That's the objective here, okay? So we've got to start with any additive component, all right? Undoing any addition or subtraction. So I identify that. That's right here, the plus 3. So to undo that, I'm going to do the opposite or the inverse operation, all right, which would be to take away 3, all right? So if I have 3, I want to subtract 3. And then I've got to remember that there's two sides to the equation, all right? I always like to draw a line right here down the equal sign, so that it always helps me know that there's two sides of the equation, which means there's balance, all right? Here's a little weight balance, all right? We're saying on this side that 2x plus 3 equals 11 on the other side, all right? The objective is to get the variable by itself, but we have to do that using math, and we have to keep both sides balanced, all right? So if I take away 3 on this side, you know, I've created an imbalance, all right? It'll look something like this, all right? And I don't want it to look like that, all right? I want it to keep balance, and so I've got to take away 3 on the other side. Well, the way that I help my students kind of remember that is the first thing when you're starting to solve equations, you have an equal side, just make two sides, all right? That helps you know. If I do a minus 3 on this side, I've got to do the same thing on this side in order to stay balanced, all right? The plus 3 and the minus 3, they cancel each other out because 3 minus 3 is 0, and 0 plus 2x is 2x, all right? So I'm carrying it on down, all right? So I subtracted the 3 here, so I had 2x left over here. On this side, I've got 11 minus 3, which is 8. All right, I do the math that I see. And now then, I can take care of my multiplicative aspect, which includes multiplication or the opposite of multiplication, which is division. In this case, it's multiplication. So I see the variables being multiplied by 2, and I want to undo that. So I'm going to have to divide by 2. And I'm going to do that to both sides because 2 divided by 2 is 1, and 1 times x is just x. And on the other side, we have 8 divided by 2, which is 4. All right? So, again, we to solve the equation, we first have to undo any additive component, which is addition or subtraction, and then we have to undo any multiplicative component, all right? Once we're done, we always want to check our solution, all right? Well, this is the solution, x equals 4, and we're going to go back to our original equation, which was 2x plus 3 equals 11, right? We're going to check our solution. This is how you do it. Right? You're going to take that 4 that x equals and plug it back in for x. We're going to rewrite the equation just like we see it, except whenever we see the variable x, we're going to replace it with a 4 inside of a parentheses. All right? Again, I just rewrite the equation just like I see it. Instead of writing an x, I write a parentheses, and then I put the value that I found inside of that parentheses, and then I do that math. I have to do 2 times 4 first, which is 8. And 8 plus 3 then is 11, all right? And we know that this is correct because after we plugged it in for our x and we did all the math, we had the same number on both sides of the equation, all right? So 11 equals x, so we know our solution was correct. X equals 4. Those are steps. It's not too incredibly difficult, all right? You just have to take care of any additive, undo any additive component first, and then undo any multiplicative component. All right, so I want you to try this one that we saw just a second ago. All right, 5n plus 3 equals 28. And if you're new to the channel, this is what I do. I try to give you a lot of examples to work through and try to have some different examples so they're going to include different kind of nuances that you'll see in solving equations. So as we go on, the examples will get more and more challenging. We start out with some kind of easy ones. But what you're supposed to do right here is just pause the video, solve it yourself on a piece of paper, and then come back and unpause it to see what the solution is. All right? So if you haven't done so already, pause the video and try it yourself. All right. We've got 5n plus 3 equals 28. All right. When we go on through, the first thing we have to do, we're going to put a line down the middle for the equal sign. We need to take care of the plus 3, which in order to undo that, we have to subtract 3. All right. If we do it on this side, we've also got to do it on this side over here, so we have to make sure that we write it on both sides. These 3 cancel out, or these 2 3's cancel out, 3 minus 3, and we have 5n left over. And on this side, 28 minus 3 is 25. And then in order to solve this on out, we have to undo this multiplication, which means we have to divide by 5. And on the other side, we have to divide by 5 as well. So we've got n equals 5, and that's our final answer. All right, n equals 5. Now we could go back up here and plug it in. 5n for n, okay, 5 times 5 would be 25, plus 3 is 28, all right, and 28 equals 28, so we know we've got the right answer. All right. And then I always have animations on my PowerPoint slides, but you can kind of see that we did the same thing with this as well. Now notice on the PowerPoint that I have it represented as a divide by 5 right here, but on my work, I have it represented as a fraction bar with the 5. That's the same thing. Fraction bar is division, all right? Okay, try this next one. 8y plus 7 equals 55. Again, pause the video, try it yourself, and then come back to see what the answer is. Okay, we've got 8y plus 7 equals 55. All right, first thing we want to do is undo any additive component, which means we're going to take care of the plus 7. We want to undo it by doing the opposite, which is to subtract 7. All right? When we have 7 minus 7, that equals 0, and 0 plus that 8y on the left side is just 8y. On the right side, we have 55 minus 7, that equals 48. Now then we can undo the multiply by 8 by dividing by 8 on both sides. All right, and you'll find out that y equals 6. All right, why don't you try the next one? This is saying p divided by 4 plus 3 equals 7. Go ahead and give it a shot. All right, pause the video, give it a shot, try it out yourself, and then come back to see if you were correct. Okay, this one right here, I want to put the document cam primary. All right, here we go. We've got p divided by 4 plus 3 equals 7. First thing we need to take care of, all right, is to undo any addition or subtraction. So if I'm adding 3, I want to undo that by subtracting 3, and I want to do that to both sides. All right? The plus 3 and the minus 3 cancel out. 7 minus 3 on this side is 4. All right? These two cancel out. They add up to 0, and that 0 can be added to this p over 4, which means we just have that p divided by 4 still left over on that side. All right? Now then we have to undo this divide by 4, so we want to do that by doing the opposite, which is to multiply by 4. If I do it to this side, I've also got to do it to the other side. These 4s then cancel out, all right, and you have p left over on this side. That equals 4 times 4, which is 16. And you could take that 16 and plug it right back in for the p up there, all right? 16 divided by 4 is 4, and 4 plus 3 is 7, and it checks out, all right? It's a good solution. All right, let's try this next one. All right, 3x minus 4 equals 23. Back to somewhat of an easy example, but now we see subtraction instead of addition. It's still the same concept. You're going to undo the subtraction first, the additive component, and then you're going to undo the multiplication. So in order to undo the minus 4, if you haven't done so already, pause the video, try it yourself. All right, in order to undo the minus 4, we want to add 4 on both sides. All right, when we do that, what's left over on the left side is the 3x. We bring that down. And then on the right side, we have 23 plus 4 equals 27. Then we want to undo the multiply by 3. We got to do that by doing the opposite, which is to divide by 3. And then on this side, the left side, you've got just x left over. And on the right side, 27 divided by 3 is 9. All right. Let's go to this next one. And on this one right here, this is showing you one of the nuances of equations that you're going to see in any given assignment, all right? You've got, in this case right here, the variables on the right side of the equation, all right? And so we don't like that, all right? It makes our heart hurt in order, when we see that, because we're creatures of habit. We always like the variables to be on the left side, right? And so now we're looking at this and just wondering, okay, is there a way to get it to the left side, all right? Well, yes, there is, all right? Let's just get a little example. I'm just going to pull some things off my desk. Let's say this bottle of hand sanitizer, all right, is equal to this paper clip and this pen, all right? Those are equal to each other. We're going to make a little equation right here. Hand sanitizer is equal to the paper clip and the pen, all right? So right now we have balance, right? Is there any reason why I couldn't just say, okay, I'm going to take this paper and pen and put over here, and I'm going to put the hand sanitizer over there, right? Did I change anything? No, I didn't. I just moved it around, all right? The hand sanitizer still equals a paper clip and a pen, all right? I just moved them. So it's okay to do this. It's okay to move things around. There's nothing saying that you can't, just so long as everything that you see on this side, you put on the other side, and then everything you see on that side, you put on this side in the exact order that you find it, all right? You write it the exact same way. So going back to our problem right here, okay, 1 equals j divided by 5 minus 7, right? There's no reason why you can't just go ahead and move those, all right? So long as when you move them, you keep everything else the same. You keep it looking just like it was. I didn't move the j divided by 5 somewhere else. That expression looked just the same. So again, we can move them so long as we write them exactly the way that we see them. Everything that was on the right side, we wrote the exact same way on the left side, and everything that was on the left side, we swapped and put it on the right side, just exactly the same way that we saw it. Now then, it looks like an equation that we're used to looking at because the variable's on the left side. All right, so in order to be able to solve this, so go ahead and solve it out now. Pause the video and solve this one out. All right, in order to be able to solve this, we've got to add 7 to undo the subtract 7. Right? And then we're going to bring our j divided by 5 down because negative 7 plus positive 7 is 0, and 0 plus j divided by 5 is j divided by 5. On the other side, we also had to add 7, so 1 plus 7 is 8. right? And then we've got now a divide by 5 that we need to undo. And the way that we undo division by 5 is to multiply by 5, just like that, all right? Once we do that, the 5's go away. You have j left over. And on the right side, you have 8 times 5, which is 40. All right, there's going to be 2 last ones. All right, I'm going to do this one. I'm going to show you one example separately. All right, I want you to try this one. It includes negative numbers here. So go ahead and pause this video and see if you can go ahead and solve this one. All right, on this one, we've got just the same kind of situation. We have an additive component that we need to undo, and then we have a multiplicative one. So the first thing we want to do is take care of the additive component. So we're going to subtract 2 on both sides. When I subtract 2 over here, I've got 2 minus 2, which is 0. And I'm going to be careful to bring this down exactly like I see it. If I see a negative 3k, I'm going to write it as a negative 3k, just right down here. And on the right side, I've got negative 22 minus 2, all right? Whenever you have a negative number, all right, that you're starting at, and you're subtracting, you're going to go deeper into the negative, all right? So we're going to end up at negative 24 when we subtract 2, all right? So this is a minus 2. All right, negative 22 minus 2, that equals negative 24. So if you got 20 out of this, then you need to go back and remember the rules for integer operations, all right? So then you've got a negative 3k equals negative 24. All right, and when you do that math, when you look at this, you've got to undo the multiplication right here. And to undo that multiplication, we have to divide by the same number, which means we have to divide by negative 3. All right, negative 3 divided by negative 3 is positive 1, and 1 times k is just k. And on the other side, you have 24 divided by 3 is 8, and a negative divided by a negative is a positive. So the answer is positive 8. And if you will, you can go back and you can plug that 8 in up here for k, all right? So negative 3 times 8 plus 2 equals negative 22. Do that multiplication, that's negative 24 plus 2. Right? Negative 24 plus positive 2, there's a war between those numbers, so they battle each other. So you're going to subtract because they're not on the same team, and then you're going to keep the sign of the larger team, just like that. And you have negative 22 on both sides, so it works. All right. One other example I want to show you. Let's do 2 minus 3k equals 8. All right? 2 minus 3k equals 8. Just like the previous example right here, all right, where we started off with a variable on the right side, all right, this does not make our heart happy, all right, this particular problem that I just gave you, all right. You've got 2 minus 3k. The reason why this doesn't make us happy is because even though the variable's on the left side like it should be, it's on the right side of the constant. And we don't like that, all right? We generally like it to be on the left side, all right? So we don't see this too often. So what I want to do is swap these, all right? But I can't swap these right now because this is subtraction. And in order to swap these, we're going to use the commutative property, which means to move the numbers. But the commutative property does not apply to subtraction. It only applies to addition and multiplication. So in order to swap these, I need to change this to an addition problem by applying keep, change, opposite. All right? I can make any subtraction problem an addition problem by applying KCO, keep, change, opposite. So we keep the first number the same in front of the subtraction. We change the subtraction to addition, and we make the next number its opposite, just like that. And now that I've applied keep, change, opposite to turn it to an addition problem, all right, I can swap these now, and I can move these around using the commutative property of addition. So I have a negative 3k plus 2 equals 8, right? And then we can just go ahead and solve it on out like normal. So you can pause the video, try to solve it, and then come back to see if you're right. All right, I'm going to put a line right down the middle. I'm going to subtract the 2 first because I need to undo any addition or subtraction. Those cancel out. I have a negative 3k left over on this side. And over on this side, we have 8 minus 2, which is 6, right? Then I want to undo the multiply by negative 3. So I'm going to divide by negative 3 on both sides. Those cancel out. And k is left over here. That equals 6 divided by 3 is 2, and a positive divided by a negative is a negative. So the answer to this equation would be k equals -2. So let's take that -2, plug that back in for k up here. All right. -3 times -2 is a +6, and +6 plus 2, it equals 8. So it checks out. All right, just fine. All right, as always, if you enjoyed the video, please hit the subscribe button down below. That helps me out with the YouTube algorithm. In addition to that, share it with your friends. Hit the like button, share it with your friends, and stick with me throughout the year. I'll help you get through 7th grade. All right, y'all have a great day. We'll see you next time.